Hello, Karibu Sana. This is Mark Griffin of the International Environment Forum, and I'm a facilities engineer and a water and sanitation practitioner. To illustrate some examples that apply to Sustainable Development Goal 6 for water, sanitation, and freshwater ecosystems, I want to share with you a field trip I made to the Ruaha Secondary School in Tanzania, the site of a social and economic development project aimed at educating girls. I was invited in 1996 to review the water supply situation there, which led to a general survey of the surrounding area and which provides some examples of SDG6 water targets. The first example is one of equitable access. The school and surrounding agricultural areas are located in the village of Kibabwa, next to a tributary of the great Ruaha River. On the other side of the river is Iringa town, or the municipality of Iringa, in the Iringa region of Tanzania. The village side of the river was rich in drinking water supply because of a natural spring or artesian well that supplied groundwater of good quality with low bacterial counts. However, the municipality used this spring as its main water source by capturing it and conveying it to Iringa town across the river, a practice which is common in water resources management. The school and village people of Kibabwa in turn received water from the municipality through a smaller pipe that crossed the river a second time. Kibabwa's water supply would often be interrupted for several months each year because the smaller pipe broke during the wet season when the river was high and fast. So the primary reason for my being invited was to find a secondary source of pumped water during these outage months, despite that the best source of water was already present but diverted to the municipality. A second piped supply came by way of a distribution pipe alongside the road, but it was not large enough to supply both the school and Kibabwa, and the water was pumped only intermittently. Additionally, the farmers of Kibabwa no longer had irrigation access to the naturally flowing waters of the artesian wellspring. As the area is water stressed during parts of the year, one would occasionally find holes drilled or burned into the large water pipe which leaked into the gardens as makeshift irrigation, and the pipe would promptly be repaired by the municipality. One would glean that the farmers felt they had a previous right to the water for irrigation. So far I've described a water distribution problem that presumes water quantity is not an issue, but water stress in the Iringa region has increased since my visit there 20 years ago. Large commercial rice farms, small subsistence farmers, hydropower, and local ecosystems are in competition for water. And for the first time, in 1993, the Ruaha River had sections with no flow for several months. Note the level of water in these photos of the hydroelectric dam at Mtera. The first one shows the reservoir at or near capacity, while the second shows it nearly empty. These examples all concern equitable access to water for people and for the economy, but they also demonstrate the need to leave enough water for ecosystems and wildlife, one of the targets of SDG 6. It also has implications for transboundary coordination and for providing renewable energy, a topic of SDG 7. The second example is one of water quality. The school facility was equipped with underground septic tanks and leach fields, normally adequate except when the river swelled and the local groundwater and surface water became contaminated. While the wet season provides a seasonal abundance of water quantity, at the same time it exacerbates a fecal contamination problem with shallow latrines and open field defecation. In addition to pathogenic contamination, local industries dumped untreated chemicals into the river. In one case, which demonstrates simultaneous biological and chemical contamination, there was open dumping from an upstream prison facility, followed by a pressure-treated wood manufacturing process, and followed by raw water draw-off for the municipal water system. So in this case, the drinking water, even if boiled to kill pathogens, contained carcinogenic contaminants from chromium and arsenic in the process at that time to make pressure-treated wood. This illustrates the need for simultaneous transboundary intersectoral management, also known as Integrated Water Resources Management, IWRM, and one of the SDG6 targets. These photos show the location where water supply was drawn from the river, visibly seen as dark and murky with floating organic materials. The suspended clay and floating organic debris is not a problem in itself, except that the water being pumped to the top of the hill in Iringa town was being treated with a form of chlorine as a disinfectant. The problem here, which serves as an example of technology transfer and education, is that chlorine mixed with organic materials creates precursors to carcinogenic contaminants. The typical industry standard is to first remove the organics with a physical coagulant process, followed by disinfection of pathogens with chlorine or similar. Regardless, disinfection today takes precedence over potential cancer in the future. Unfortunately, a choice to be made without the necessary coordinated efforts to provide sustained quality of drinking water. A coordinated effort near the Ruaha Secondary School and Iringa town is necessary and beneficial on a local level, but the scale of IWRM needs to be much larger. In this case, a management plan might address the Great Ruaha River Basin that covers the Iringa and Dodoma regions of Tanzania, and include the Ruaha National Park with its wildlife and ecosystems, the Mtera and Kidatu hydroelectric dams, and the controversial commercial rice farms upstream of the Ruaha National Park. These topics are in addition to the standard irrigation, fishing, and watch sand activities of local residents, and there is currently a struggle to decide which water uses take precedence for the overall good. This is also an opportunity for increased water efficiency, another target of SDG 6. There were many examples of local cooperation. Danita was on site and assisted with background information about local water use. The Iringa Water Department Quality Laboratory tested water samples I had taken in the area. The school staff was very helpful and loaned me a small motorcycle for transportation. And a student's family assisted with materials and manpower in exchange for my assistance in the design of the irrigation system at their farm. Several important lessons learned during my visit remain. The first regards technology transfer and supply chains. I attempted to design and build a small Western-style water treatment plant to produce water suitable for drinking without boiling it. All or most of the required materials were local, but some items would need to be shipped, in particular the coagulating and disinfecting chemicals. Once built, trained operators would need to maintain safe operations and maintenance of the plant. Whereas trained persons and the required supplies could not be guaranteed, I recommended that water continued to be boiled before drinking. However, when I reported this to the school staff, they laughed at me because they knew the water had to be boiled. They just didn't want to have to carry it. So I had listened to what I thought the needs were and not the requests they gave me. I didn't listen, and this was another lesson learned. Today, I might go a step further and attempt a more formal consultation with representatives from area stakeholders, but my purview was somewhat restricted to the school, with which there was ample consultation. Although a modern treatment plant, an elevated storage and distribution system was conceivable near the school, it was not practical. Energy was also an issue because electricity was very expensive, so running a treatment plant in that setting would have been cost prohibitive. Also, I lived in the same quarters as the teachers who burned fuel indoors for cooking. I offered to get them electric cook stoves, but I learned that they couldn't even afford the electricity to run them. It was more than the capital cost of the equipment. This regards equitable access to energy, SDG 7. When I returned home, I began studies of how slow sand filtration that uses no chemicals and less energy for pumping, but uses more land and is labor intensive. Nonetheless, more appropriate for this setting, again a matter of technology transfer. As part of the facilities review, I collaborated with students and the staff to create potential applications for renewable energy. The two most notable ideas were solar hot water bags placed on roofs and a small windmill that pumped water directly. To my knowledge, these were not implemented, but today solar panels would be a likely choice. The students typically cut the grass by hand, so I investigated buying a gasoline-driven lawnmower, but the cost, including a hefty tariff, was prohibitive. My stay in the village of Kibabwa in the suburbs of Iringa lasted a short 8 weeks, but I learned many lessons and gained some close friends. Waterborne diseases were the main topic of my visit, but malaria was a harsh reality of living there, and the medications available at that time restricted my visit to that duration unless I took other measures for a much longer stay. Just before I arrived, the daughter of a couple who became close friends died from malaria, mainly due to a lack of resources. Perhaps mosquito control could be another consideration of integrated water management, but I am unqualified to assess this adequately. The greatest personal outcome to me was that it demonstrated how we take water for granted in the West, and how we consume it apparently without regard to the purification processes and energy requirements involved. This changed my career to focus on the sustainability of water resources from that time onward. Thank you.